Workplace injuries can occur at any time, even when precautions are taken. Following safety protocols, wearing appropriate protective gear, and maintaining awareness of potential hazards are crucial in any work environment. Let's examine several real-life workplace injury accounts and extract the crucial safety lessons they provide. One account involves setting up a heavy conference table with a coworker. The legs on one side collapsed, causing the table to fly through the air, narrowly missing one of the workers and crashing into a nearby wall. The lesson here is to always inspect equipment for stability and integrity before use. This includes tables, scaffolding, and any other equipment designed to bear weight. Ensure that all legs, supports, and locking mechanisms are functioning correctly. A second account describes working on an electrical panel and accidentally touching a live wire. The individual experienced a surge of electricity and was thrown backward, escaping with minor burns and shaken nerves. This highlights the importance of electrical safety procedures. Always de-energize circuits before working on them whenever possible. Use lockout-tagout procedures to prevent accidental re-energization. If working on live circuits is unavoidable, use appropriate personal protective equipment, or PPE, such as insulated gloves and tools. Maintain a safe distance from live parts and be aware of potential arc flash hazard. Another account involves a fall from a ladder while reaching for a high shelf. The ladder slipped, resulting in a fall that caused a hairline fracture. Ladders must be used correctly to prevent falls. Ensure the ladder is placed on a stable, level surface. Use the correct angle, typically a 41 slope. Never overreach, and maintain 3 points of contact at all times. If the task requires frequent reaching or is at a significant height, consider using a safer alternative, such as a scissor lift or aerial work platform. A fourth account describes the malfunction of a hydraulic lift, resulting in a hand being pinned against the wall. This caused a broken wrist and bruising. When working with hydraulic equipment, always follow the manufacturer's instructions and safety guidelines. Inspect the equipment regularly for signs of wear or damage. Never exceed the load capacity of the lift. Ensure that all safety devices, such as emergency stops and pressure relief valves, are functioning correctly. Never place yourself in a position where you could be trapped or crushed by moving parts. A final account involves a chemical spill in a laboratory, resulting in severe burns. This emphasizes the importance of handling chemicals safely. Always wear appropriate personal protective equipment, including gloves, eye protection, and a lab coat. Know the properties of the chemicals you are working with and follow the proper handling procedures. Have spill control materials readily available and know how to use them. In case of a spill, immediately notify others in the area and follow the established spill response procedures. These stories, though varied, underscore common themes. Firstly, hazard identification is paramount. Before starting any task, take the time to identify potential hazards and assess the risks involved. Consider factors such as the equipment being used, the environment, and the potential for human error. Secondly, proper planning is essential. Develop a plan for how to safely perform the task, taking into account the identified hazards and risks. This may involve using specific tools or equipment, implementing control measures, or modifying the work process. Thirdly, training and competency are crucial. Ensure that all workers are properly trained and competent to perform the tasks assigned to them. This includes training on the safe use of equipment, hazard recognition, and emergency procedures. Fourthly, the use of PPE is vital. Wear appropriate personal protective equipment for the task being performed. This may include hard hats, safety glasses, gloves, hearing protection, and full protection. Ensure that the PPE is in good condition and fits properly. Fifthly, housekeeping is important. Maintain a clean and organized work environment. Remove clutter, dispose of waste properly, and keep walkways clear. This reduces the risk of trips, slips, and falls. Sixthly, communication is key. Communicate effectively with coworkers about potential hazards and safety concerns. Use clear and concise language and ensure that everyone understands the instructions and procedures. Seventhly, regular inspections are necessary. Inspect equipment and work areas regularly to identify potential hazards. This may involve visual inspections, functional testing, and the use of specialized equipment. Eighthly, incident reporting is crucial. Report all incidents, even minor ones, to the appropriate authorities. This allows for investigation and corrective action to prevent similar incidents from occurring in the future. Ninthly, continuous improvement is essential. Continuously review and improve safety procedures based on experience and feedback. This may involve updating training programs, modifying equipment, or implementing new control measures. Tenthly, always be aware of your surroundings and maintain a safe attitude. Pay attention to what is happening around you and be proactive in identifying and addressing potential hazards. A safety-conscious attitude is essential for preventing accidents and injuries. Workplace safety is not just the responsibility of management. Every worker has a role to play in creating a safe work environment. By following safety protocols, using PPE, and being aware of potential hazards, you can protect yourself and your coworkers from injury. Remember, safety is everyone's responsibility. Specific electrical safety measures should be followed in reference to the National Electrical Code, NEC, and other safety standards. For example, Article 110.3 of the NEC requires that all electrical equipment be installed and used in accordance with the instructions included in the listing and labeling. This means following the manufacturer's instructions for proper installation and operation. Article 110.16 requires that electrical equipment be marked with a warning label indicating the presence of arc flash hazards. This label should include information such as the voltage level, the approach boundary, and the required PPE. Article 130 addresses work practices for electrical safety. It requires that qualified persons be trained in the hazards associated with electrical energy and the proper procedures for working on or near energized equipment. It also requires that a job safety analysis be performed before starting any electrical work. Article 230 addresses service entrances, which are the point where electrical power enters a building. It specifies the requirements for the size and type of conductors, overcurrent protection, and grounding. Article 250 addresses grounding and bonding, which are essential for preventing electrical shock hazards. It specifies the requirements for grounding electrodes, grounding conductors, and bonding jumpers. Article 300 addresses wiring methods, which are the rules for installing electrical conductors. It specifies the types of wiring methods that are permitted in different locations and the requirements for supporting and protecting conductors. Article 310 addresses conductors for general wiring. It specifies the ampacity of different types of conductors and the requirements for dirting conductors when they are installed in certain conditions. For example, Table 310.15. B16 provides the allowable ampacities of insulated conductors rated up to 2000 volts, 60 degrees Celsius through 90 degrees Celsius, not more than 3 current carrying conductors in a raceway or cable or earth, based on ambient temperature of 30 degrees Celsius. Article 400 addresses flexible cords and cables. It specifies the types of cords and cables that are permitted for different applications and the requirements for their use. Article 408 addresses switchboards and panel boards, which are used to distribute electrical power throughout a building. It specifies the requirements for their construction, installation, and overcurrent protection. Article 430 addresses motors and motor circuits. It specifies the requirements for the size and type of conductors, overcurrent protection, and motor controllers. Article 440 addresses air conditioning and refrigerating equipment. It specifies the requirements for the size and type of conductors, overcurrent protection, and disconnecting means. Article 500 through 516 addresses hazardous locations, which are areas where there is a risk of explosion or fire due to the presence of flammable gases, vapors, or dusts. It specifies the types of equipment that are permitted in different hazardous locations and the requirements for their installation. Article 600 addresses electric signs and outline lighting. It specifies the requirements for their construction, installation, and wiring. Article 700 addresses emergency systems, which are designed to provide power to essential loads during a power outage. It specifies the requirements for their design, installation, and testing. Article 701 addresses legally required standby systems, which are similar to emergency systems but are required by law. Article 702 addresses optional standby systems, which are designed to provide power to non-essential loads during a power outage. Article 705 addresses interconnected electric power production sources, which are systems that generate electricity and are connected to the utility grid. It specifies the requirements for their design, installation, and operation. These NEC articles provide a framework for electrical safety. However, it is important to consult the full text of the NEC and other applicable standards for specific requirements. Regular safety audits and inspections can help identify potential hazards and ensure that safety procedures are being followed. These audits should be conducted by qualified personnel who are familiar with the NEC and other applicable safety standards. Electrical safety training should be provided to all workers who may be exposed to electrical hazards. This training should cover topics such as hazard recognition, safe work practices, and the use of PPE. Lockout-tagout procedures should be implemented to prevent accidental energization of equipment during maintenance or repair. These procedures should be followed strictly and should be regularly reviewed and updated. Arc flash hazard assessment should be conducted to determine the potential for arc flash incidents. These assessments should be used to select appropriate PPE and to develop safe work practices. Electrical equipment should be regularly inspected and maintained to ensure that it is in good working condition. This includes checking for loose connections, damaged insulation, and other potential hazards. Grounding and bonding systems should be tested regularly to ensure that they are functioning properly. This helps to prevent electrical shock hazards. Overcurrent protection devices, such as circuit breakers and fuses, should be properly sized and maintained to protect against overloads and short circuits. Flexible cords and cables should be used properly and should not be damaged or overloaded. Switchboards and panel boards should be kept clean and dry and should be properly labeled. Motors and motor circuits should be properly protected against overloads and short circuits. Air conditioning and refrigerating equipment should be properly installed and maintained to prevent electrical hazards. Hazardous locations should be properly classified and equipped with approved equipment. Electric signs and outline lighting should be properly installed and maintained. Emergency systems should be tested regularly to ensure that they are functioning properly. Legally required standby systems should be tested regularly to ensure that they are functioning properly. Optional standby systems should be tested regularly to ensure that they are functioning properly. Interconnected electric power production sources should be properly designed, installed, and operated to ensure safety. Safety is a continuous process that requires ongoing attention and effort. By following these guidelines, you can help to create a safe work environment and prevent electrical accidents and injuries. Keep your workplace safe.